The channel not only explains technology, it designs the future. If you want AI, data science, and real-world tech mastery, welcome to Technical Professor.
Hello everyone, welcome back to Technical Professor. So in this lecture, we are going to discuss about optimization for machine learning. So in previous lecture, we learned how data is represented and how uncertainty is handled and how statistics help us to understand data. So now come the most important question. How does a machine learning actually learn? So the answer is optimization. So why optimization? So machine learning models start by making bad predictions. All right. So optimization the process that helps uh, models improve over time. So optimization allow ML models to learn from mistakes and from errors, and it reduce errors and improve predictions step by step. All right. So without optimization, machine learning would never improve. So let's learn about loss function. And what is loss function? Loss function measures loss function measures how wrong a model prediction are. Okay. So a loss model function quantify how well a machine learning model performs by measuring the error between predicted and actual values. So it is guiding optimizing to improve predictions. So thinking of loss as a scorecard. All right. And penalty, a measure of error. So lower loss means better performance. Okay. So now we are going to understand what are common loss functions. So it is different programs use different loss function. So MSC stands for mean square error. So it quantifies the average squared difference between predicted and actual outcomes. So making it a widely used metrics in regression tasks. And MAE also a mean absolute error. So it measures the average absolute difference between predictions and actual outcomes. It providing a robust metrics less sensitive to outliers than MSC. So log loss also a logistic logs. It evaluate the performance of a classification model with probabilistic outputs and focusing on the accuracy of a predicted probabilities. So let's understand about MSC. It is mean squared error. So mean squared error is one of the most common loss function. So it squares the difference between actual, predicted, and square ensure. It is used to handle large error or penalized score, and errors are always positive. So this help the models focus on big mistakes. All right. So now we are going to understand loss curve function. So understanding loss curve help visualize how the model error changes our iterations and enabling better tuning of parameter for optimal performance in machine learning. So let's run. So at the beginning, loss is high, and loss after loss decrease. So good models show a smooth curved downward curve. This tells us learning is happening. All right. So optimization goal. So more the main goal of optimization is simple. So minimize the loss function. That is this minimize. I will write this also. So minimize the loss. All right. So Now it is perfect. So now we are going to understand what is gradients. So gradient represents the slope of the function and indicating its direction and rate of change also. So they are crucial for optimizing machine learning models during training. Alright, so gradient tell us which direction move to reduce loss. So imagine you are standing on a hill and gradient tell you which way is downhill. So in ML, gradients guides the learning process. It means it act as a guide. All right, so you can see the definition now. Yeah, perfect. So derivatives. So a derivative is the rate of change, and in machine learning, it tell how the change loss changes when parameter changes. So this is why calculus is important in ML. Mhm. Now we are going to understand what is gradient descent. All right. So gradient descent is an iterative optimization algorithm that helps minimize loss by adjusting parameters based on gradients. All right. So it uses gradients, takes small steps and moves toward minimum loss. So it is the most widely used optimization technique in ML. So what is formula for gradient descent? The updated formula will be so W equal to W minus alpha derivative of L relative of W. All right, so W is the parameter and alpha is the learning rate and gradient shows direction of change. So this formula is applied again and again until learning stops. All right, so now we are going to understand what is learning rate. So the learning rates control step size. So it is too small and learning is small. If it is too small, learning it's visible or not. Too small learning. Slow. Okay. It's visible. If too large, never converge. Okay, so choosing the right learning rate is critical. All right, so now we are going to understand step by step process. So it is the iterative optimization method used to minimize loss by progressive adjusting parameters. So the process is first one is making prediction, calculate loss, compute gradient, update parameter. Then fifth one is repeat. So this loop continues until loss stops decreasing. Now we are going to understand convergence. So the convergence occurs when the model reached its minimum loss and the learning has stabilized. So at this point, further training does not improve performance. Reach minimum loss. All right. So Now we are going to understand local versus global. So a global minimum is the best solution, and local minimum is good but not perfect. All right, so let's understand. Local is good, not perfect. Global, best. All right, so ML models in some time get stuck in local minima, especially with complex data. So, what are types of gradient descent? So, understanding different gradient descent approach. So, let's start it. So, the first one is batch gradient descent, and second one is stochastic gradient descent. Third one is mini batch gradient descent. So, each has own advantage and trade-offs. So, you can see the definitions. I will go side. Right, I'll try to you're able to watch. Let's see. All right. So now we are going to start with batch gradient descent. Let's understand batch gradient descent. So batch gradient descent use the entire data set at once. I will write it. Entire data set. So what are pros there? It is stable, updates, stable updates, cons, slow, memory intensive. So these are cons there. So it is rarely used for large data sets. So these are pros and cons. And stochastic grading can be faster than batch method, but may result in more noise during convergence. Let's understand mini batch gradient descent. So mini batch gradient descent is a balanced choice that combines speed and stability for faster trading. All right. So it uses small batches of data. It's faster but more stable. I can write one line. Faster and more stable. Okay. So optimization challenges. Optimization not always easy, and common challenges are slow convergence, oscillation, getting stuck in local minima. These are some challenges. All right. So These issues required careful training. So now we are going to understand vanishing and exploding. So in deep neural network, gradient can be become very small or very large. So this make training difficult and stable. So vanishing and exploding gradient can severally impact training efficiency and model performance in deep learning system. Okay. So neural network use back propagation uh, and computes gradient layer by layer, and it updates millions of parameters efficiently based on gradient descent. So what is back propagation then? So back propagation is critically algorithm for training neural networks and helps minimizing error through effective weight adjustment. All right, so let's learn more to linear regression. So linear regression optimize demonstrate how gradient descent minimize prediction error for effective model learning. So in linear regression, we start with random weights, calculate predictions, and measure loss and update weights. So over time, prediction become more accurate. So common beginner mistakes are using wrong linear data and over training the model, ignoring loss curves. So, so what is summary of today? So optimization teach machine how to learn, and gradient descent minimize. So learning rate controls and speeds and stability. So in the next lecture, we are going to learn regularization and overfitting and how to build models that generalize well. So if this lecture help you understand optimization, and like the video and comment regularization for next lecture. Thank you so much for watching this video.